All right, in this video, we're going to be talking about mass moments of inertia. All right, so first things first, the mass moment of inertia is just pretty much the measure of a resistance for an object to rotate based on its mass. And the best thing about these is that equations are all found in the FE reference handbook. It'll be under the section of dynamics, but they're all tabulated. So just some things you need to know from that table is that M equals mass, L equals length, R equals radius, H equals height. And the table in the FE reference handbook even has like little figures drawn with everything labeled. All right, so you really don't need to know a lot in order to solve these problems. You just need to know where in the reference handbook to look. For example, if you had a slender rod, and let's just say of a length of 2 inches, and we wanted to find, and it has a mass of 0.5 pounds, and we wanted to find the mass moment of inertia about the y-axis about its own centroid. So what that means is if we have this slender rod, got a centroid here, and then the y-axis would be here. So this would be the y-axis about its centroid. All right. Now for our particular rod, this would be 1 inch, this would be 1 inch. Okay. So again, you look up in the table and you can see that IYC equals ML squared over 12. So that would just be 0.5 times 2 squared over 12. Plug in your calculator, you get 0.167 pound inches squared. All right, so it's really as simple as that. But if you wanted to move this y-axis somewhere else, say here, it's 0.5 inches. So now you just want IY. You can take your IYC and then just add MD squared, where this is the mass and this is the distance between YC and Y. So you would get that 0.167 plus 0.5 times 0.5 squared. So 0.5 squared times 0.5 plus, and you would get 0.292 pound inches squared as your new answer. All right, so yeah, that should pretty much cover it. So go ahead and try a couple of these on your own. So for the first one, Say slender rod with M equals 5 pounds. L equals 3 inches. Centroid is at 1.5 inches. And we'll give you IYC as being 3.75 pound-inches squared. We just want you to find IY if we stick, this is our y-axis. So find the mass moment of inertia about this axis here. All right, and then for the next one, we're gonna have a thin circular disc where radius equals 10 inches and mass equals 7 pounds. And we're just finding mass moment of inertia about the x-axis. Go ahead and solve those out, then check your solutions with the PDF. And that should cover it for mass moment of inertia.